This is the brief rundown on all the stuff about volume for these simple, pretty common shapes. So here we have all the 2D formulas. The 2D formulas are ones you should already know, or at least like have seen a couple times, especially, well, actually all of these. These may be new to you if you're in geometry for the first time, but length times width, we learned that pretty early on, so that's not too bad. And in fact, all of these shapes can be used to make prisms. Prisms are just like the shape, like here's a circle, stretched out. So you can imagine like a cylinder, like a Pringles can. This same circle has now been stretched a distance, and I'm going to call that distance L for like length. So this formula, now we're talking about a 3D shape here. So this is going to be the volume of the shape, meaning like how much stuff it can hold or how much space it's taken up. So the volume, how this is obtained is by using this base shape. Actually, let me show you another example here. Here's a triangular prism. So here you can see in this shape, the triangle has been stretched, you could think of it, to make this shape. So the very same triangle that was there before is still there and has now just been like moved in this direction. You could think of it that way. Because what we're really after is we're after like the base shape, this circle or this triangle, or in the case of a rectangle, it might look like this. So you can see how this like front shape here, this rectangle has been stretched, elongated. Oh man, I feel like I'm just saying the same thing. So let's just get on with it. If you take any prism, no matter what, any prism will have a volume. That's too big actually. Each prism, no matter what, will have a volume that is given to us. Let me put it down here. Given to us as the base of whatever shape makes that prism times the length of that prism. So going back to our examples here, we have this circle is the one being stretched. So find the circle formula. And really, I can see why this is confusing. I called all these A for area, and now it's like find the base area. Here they're called A, here it's called B. I just realized that's like the same thing and could be very confusing because the base area for this is this shape, the area of a circle. So that is pi r squared times length. Wow. Well, let's just deal with it and move on. This, just think A and B here, capital A, capital B, these are basically the same. No, they are exactly the same. The base area. Find your base shape. There's my base area. So I'm going to do that, big B, 1/2 base times height, times L, however long that shape is, or however far it's been dragged. This one has a length and a width, yes, but it also has a height, or yeah, height. And so the volume here, the volume is going to be length times width, the area of the base, times that distance. In our case, I already had a length and a width, so I called this one height. And I'm just going to draw those three because those are the most common, but it's not like they each have their own formula. It's all this over and over again. If you understand how this works, you can do things like a trapezoidal prism, which you should maybe think about that for a sec, and think about what that formula would look like based on these other ones. That's a horrible trapezoid prism. Every pyramid has a base, so you need to identify what that base is. In this case, it looks like a rectangle. In this case, it is a triangle. And in this case, it is a circle. So if you're having trouble like identifying what the base is, I guess you could think, if you were going to set down the pyramid so that the spiky part was on top, it's where you would set down the pyramid. So the volume in each one of these pyramid cases, I guess I should have written this first, but for any pyramid, no matter what, here, these are just three examples. We could have a trapezoidal pyramid or a hexagonal pyramid. All of them, though, you can calculate as 1/3 of a prism, basically. So 1/3, and then you calculate it just like we did over here. This time, well, I'm going to call it L since I called it L over here. So like the length or the height of a pyramid is going to be from the bottom of the pyramid. Well, I guess here's like the bottom, all the way to the top. So that's what I'm calling L. You know what? I'm just going to call it height because that's kind of confusing. For all of these, this is what this boils down to. Each one of these shapes is calculated exactly the same way with this, but you have to figure out what B is for each one. That's the key. So for this volume, I know it is a pyramid, so it's going to be 1/3, and I know the height's going to be over here. So I'll just put height. And then the base, which is a rectangle, come over here. Here's rectangle, length times width. So it's going to be length times width. All right. Next one. This is a triangle. Find the triangle area. This is going to be 1/3 of triangle area. So that's going to be 1/3 of 1/2 base times height, because it's a triangle base, times the height of the entire pyramid. All right. Next one. This one typically is weirdly presented as a separate formula, but it's not. It's the same. It's 1/3 the area of the base, which is pi r squared, and I got that over here, times the height of the pyramid. So those are just 3 examples. No matter what though, it's this. You find the area of the base, plug it in, you're done. Sphere is like a 3D circle. It's like a ball or the moon or a marble. It has a formula that is given to us like this: 4/3 pi r cubed. Typically it's just kind of given to you, or you can just look it up. And this radius here is really the only spooky part, and that's just like it used to be from the center of the circle to the edge, now it's from the center of the sphere to the edge of the sphere. Basically the same though. So you can just plug that in. You know, if that was 10, you just plug in a 10 there, and that's your answer. Here's something else that shows up quite a bit though. Right here, this is called a hemisphere, and hemisphere are 1/2 of a sphere. So if you know how to calculate the volume of a normal sphere, I mean, like, look at this one, it's got that equator. Imagine I just sliced it right down the middle there, and this is just half. So your volume for this would just be 1/2 of the sphere. It's not like a whole new formula. You just gotta know how to think about it. All right, that's volume 1. All right.